Advanced robotics uses clever sensor technologies, including as ultrasonic, touch, and light sensors, to interact with the physical environment. It combines complex programming with strong hardware. In today's video, we'll talk about 8 advanced robot animals you need to see. Number 8. E-motion butterflies. The complex problems that could develop in the realm of production in the future are shown by the bionic butterflies. These problems include real-time effective network communication between various components, functional integration, and ultra-lightweight construction. A startling illustration of how the real and virtual worlds may survive and even thrive together are the e-motion butterflies. Throughout the bionic learning network, the capacity to fly often appears. The engineers used the knowledge they had gained from working on earlier bionic projects with the so-called e-motion spheres to create the bionic butterflies. They do this by fusing a group's coordinated flying behavior with the artificial insect's very lightweight construction. An external, well-connected guiding and monitoring system manages the coordination of the various flying objects in a secure and autonomous way within three-dimensional space. An indoor GPS system is used to ensure that the butterflies move as a flock without running into one another. This system combines communication and sensor technologies. Number 7. BionicOpter. Our bionic learning network was able to technically replicate the Dragonfly's very difficult flying qualities thanks to the BionicOpter. The use of lightweight materials and functional integration enabled this. The ultralight aircraft can fly in any direction, hover still, and sail without moving its wings, much like the genuine bird that served as its model. For the first time, a model has been developed that can handle more flying scenarios than helicopters, powered gliders, and unpowered gliders put together. This unique flight pattern is only possible because to a design approach that has previously been shown to be crucial in the creation of the smart bird. On board in highly tight spaces, components including sensors, actuators, and mechanics are installed and paired with control and regulatory technology. The artificial Dragonfly's wingspan is 63 centimeters and its body length is 44 centimeters, although it only weighs 175 grams. The wings are constructed of a carbon fiber construction that is covered in a thin foil. The ribcage also stores the battery's 9 servo motors and a powerful ARM computer, in addition to the sensors and radio modules. The radio modules are also housed in the ribcage. The whole system may be flexible while still being very light and extremely sturdy because to the use of elastic polyamide and terpolymer in its manufacture. Number 6. Spot Mini. A robot that can move about in different environments such as workplaces, residences, and even outside. It can even manipulate things and climb stairs. The Spot Mini is able to navigate obstacles that bigger robots cannot. Spot Mini is able to do tasks such as opening doors thanks to an accessory that resembles a snake and can be attached where a real dog's head would be. The primary chassis of the robot has a battery with a quick-release connector, stereo cameras in the front, side cameras, and a back cam. However, the primary chassis of the robot is also capable of being modified with a number of attachments on the top, one of which is an articulated arm. The creation of Spot Mini was inspired by the idea of creating a product that is versatile enough to be used in a variety of settings, including a house, an office, or another accessible location. In order to accommodate a wide variety of uses, third parties will be able to design and manufacture systems that are compatible with Spot Mini. At the moment, it is equipped with a surveillance package that consists of specialized low-light cameras that are installed on the back. Additionally, a camera is fixed in the arm, and the computer is able to accept user code. Number 5. Cheetah Robot. The Cheetah Robot is a speedy 4-legged machine that is capable of running and doing backflips. Because it is durable and equipped with strong actuators, researchers are able to conduct tests and evaluate new controllers without worrying that they may damage the robot. The Cheetah Robot is a 4-legged, 4-wheeled quadruped that was created by Boston Dynamics with support from DARPA. It recently blew through its previous speed record, reaching a top speed of 28.3 mph, which is nearly 0.5 mph faster than the fastest 20-meter split ever run by Usain Bolt. This iteration of the Cheetah Robot is powered by an off-board generator and operates on a treadmill. Early on in the next year, testing will begin on an untethered outdoor variant. Number 4. BionicANT. Robo-ants exhibit cooperative behavior that is modeled after that of wild ants. The BionicANT, much like their natural forebears, cooperate according to a set of well-defined norms. They are able to coordinate their activities and motions among one another because of the communication that takes place between them. The independent individual components of the artificial ants illustrate how, when working together as part of an overarching network system, they may accomplish a difficult job. This kind of collaborative behavior offers some intriguing new directions for research that may be used in the factory of the future. The production systems of the future will be based on bionic components that are intelligent and can adapt themselves to a variety of production circumstances. As a result, they will be able to take on responsibilities that are assigned from a higher control level. As a part of its bionic learning network, the German automation firm Festo came up with the idea of creating BionicANTs. These robot ants operate autonomously while cooperating with one another to accomplish their goals. The firm is developing technologies that may be used to automate manufacturing via the use of biomimicry, which is the process of combining elements of nature into the construction of mechanical systems. Number 3. Aqua penguin. Much like their biological inspiration, the aqua penguins feature an energy-efficient flow pattern. The artificial penguins are able to swim in the opposite way from their real counterparts and can maneuver through the water in even the tightest of spaces with the help of their wings. When they are in a group, they are able to orient themselves separately and develop a variety of behavioral patterns. Penguin is a fascinating animal because it has evolved a variety of survival strategies to enable it to thrive in the icy waters of Antarctica. They do this by having a flow-optimized body, which reduces their total energy consumption. Nature once again shows how a little quantity of energy input may produce a big boost in performance. There is enough rationale for our bionic learning network to study and technically implement the efficient flow pattern of birds in the aqua penguins. The aqua penguins are equipped with a specific 3D sonar that enables them to communicate with both their surroundings and other bionic penguins. Similar to dolphins, they employ broadband ultrasonic waves to establish their position in space, continuously gauge their distance from the water's margins, avoid collisions, and freely travel. With the use of a different pressure sensor, penguins can gauge depth while they are in open water. Number 2. Robot Dragonfly. Engineers at Festo in Esslingen, Germany have created a small and lightweight unmanned aerial vehicle 𝐦𝐤𝐤 capable of emulating a dragonfly's flying qualities. The BionicOpter robotic insect can glide, hover, and accelerate swiftly without flapping its wings. It is heralded as the first aircraft that can fly like a glider, a plane, and a helicopter all at the same time. Its extraordinary mobility is attributed to its lightweight design, superior controls, tight component integration, and the ability for each of its 4 wings to move independently. The 44 centimeter long, 175-gram Bionic Dragonfly has a 63 centimeter wingspan and weighs relatively little. A 7.6-volt LiPo battery, 9 servo motors, a high-performance ARM CPU, inertia, acceleration, and position sensors, as well as wireless communication modules and other components are housed in its compact rib cage. A motor at the housing's base drives the 4 wings at a common beat frequency that may be adjusted between 15 and 20 Hz. The amplitudes of the wings flapping are controlled by 4 motors located at the wing joints. Linear movement in the wing root may vary the deflection between 80 and 130 degrees. Number 1. Bionic Kangaroo. The Bionic Kangaroo robot model, which is fashioned like a kangaroo, was created and produced by Festo. The movement of kangaroos was studied, and Festo's researchers and engineers utilized that knowledge to create a robot that moves similarly to kangaroos. These strategies are based on kinematics, bionics, and biomimetic theories. By saving the energy it obtains from each hop so that it may utilize it for future hops, the robot imitates the behavior of real kangaroos. New driving theories and movement patterns have always been heavily emphasized by the bionic learning network. As a result, we concentrated on the kangaroo and its distinctive way of moving and attempted to incorporate this into the technical design of the bionic kangaroo. Like its natural precursor, it is able to recuperate the energy it expends while jumping, store it in its Achilles tendon, and then use it effectively during the next jump. These were 8 advanced robot animals. Let us know which one amazed you the most in the comments. Make sure to click on subscribe button before leaving. We'll see you in the next one.